Now let's have a look at this case study, which is the case study of a pulley bracket. So here is a pulley which is shown over here as a circle, which is mounted to this bracket through two holes. And this pulley is exerting a force of 500 Newton downwards and 500 Newton towards the right, as shown over here. And this arrow indicates the resultant force which is exerted by the pulley onto the bracket. So 500 Newton towards the right, 500 Newton towards down, and this is the base design which we are having, and the back surface has to be fixed. So the back surface of this plate is to be fixed, and the force is applied at the cylindrical surfaces of the bracket as shown. So the cylindrical surfaces of the bracket are the areas which are going to be taking the load. The material over here is steel with the weight of 170 grams. So the weight of this component as shown in this image is 170 grams. The target stress value which we want to achieve is below 150 megapascal. So the target stress which we are trying to achieve is 150 megapascal. So this component will be attached to a wall and will be bonded at the back surface. Hence we are applying a clamped constraint or a fixed constraint on the back surface, and then we are only interested about this bracket and not for the full assembly, and we want to optimize the design of this bracket. So let us see. So here are two alternative concepts which I have devised to meet the requirements of lowering the stress value. So here is concept number 2, which is a very basic sheet metal bracket. Sheet metal bracket having two bends as shown over here, and the back surface of this bracket will be fixed or clamped. Over here is a machining based or a casting based bracket, which is a bit more bulkier, and the back surface again will be fixed, and here there is a cutout given for the clearance of the pulley. Comparing the individual component weights, 170 gram is for the concept 1, which is the base concept. Concept 2 being sheet metal is lighter in weight, 152 grams. Concept 3 is bulkier, so it's almost double that of the sheet metal concept, so 341 grams. The analysis setup is very straightforward, as is similar to what we had seen earlier. So the back surface is constrained, it is fully fixed, and the load is applied as shown, 500 towards the side, 500 downwards. So the stress value which is noted for base concept, we are seeing a value of 212 megapascal, which is showing a concentration at the back of this sheet metal part. So at the weld there will be a concentration of 202 megapascal. For this sheet metal bracket, the stress value is lower, which is 122 megapascal over here, and for this casting part the stress value is even lower, which is at 24 megapascal. So the 24 megapascal is for this casting part, whereas for the sheet metal part is 122 megapascal. So for selection, this is appropriate for selection because it is lighter in weight also, and the stress value has also reduced from 212 to 122 megapascal. Here are the deflection values. So in terms of deflection also, with respect to the base concept, this is better. The sheet metal concept is better, purely sheet metal concept is better, which is 0.06955 mm. And the casting concept is even better, 0.01054 mm. But because of the weight penalty, this concept is a better choice.